Okay, in today's lesson for week 21, we're going to solve systems of equations by both substitution and graphing. So this first one right here, both of these equations have which variable isolated? On number one. Which equation, or what's the variable that's isolated in number one? The bottom one, which variable is isolated? X is all by itself? It's the y. Is there another equation that also has the variable isolated? Which one? The first or the second? Or both? Both of them. So on this one, we are going to take this expression right here, and we are going to substitute it in for the y. Since both of these are equal to y, to solve this one by substitution, we are going to have negative 2x minus 5 is equal to x minus 2. Talking to Mr. Ramos, this is the number one confusing type of system that we have. For some reason, students have a hard time with if they're both equal to it, like, what do I do? If I have variables on both sides, like, I don't know, I'm stuck. So the goal when you have a system of equations is to come up with the new equations combined by the two given, and your new equation should have only x's or only y's. This one only has an x. So are we going to solve for x or y? X, right? Because there's only an x. So it's our job to put all the x's on one side of the equation and all the constants on the other. Do we want the x's on this left side or the right side? Okay, we'll go to the left. It doesn't matter as long as we follow all the math rules. So I want this x over here. The opposite of a positive x is negative x. So these right here cancel out. I owe somebody $2 and I owe somebody else another $1. What's my total for negative 2x and negative x? Negative 3x. Then everything else just comes straight down. What is our next math move for this? Add 5. Okay, we're going to add 5 to both sides. So then we have negative 3x is equal to, what's negative 2 plus 5? Okay, 3. And what's our last move to solve for x? So x is equal to a positive 1 or negative 1? Most students, I'm done. If you put this into your answer, you're going to get 0 points. You have half of the answer because the directions do say express the solution as an ordered pair, so we need the y value. So now that we know x is this one, it does not matter which equation we choose. We can choose the top or the bottom. For me, the bottom equation looks a little bit simpler, so I'm going to take this negative 1 and I'm going to substitute it in here. So y is equal to negative 1 minus 2. And what's negative 1 minus 2? So if we express our solution as an ordered pair, it's always x, comma, y. So this is the solution to the system of equations, and here's our process for solving it by substitution. We are going to take the same system, and we're going to see if we graph it, can we get the same answer of negative 1, comma, negative 3? So this is the stuff we've been working on since late September. To graph these lines, this first equation has the y-intercept of what? What's my y-intercept up here? Negative 5. So I'm going to go to the y-axis. Find negative 5 and put a point. What is our slope on this first equation? Negative 2. And I can make it a fraction to make it rise over run. So I'm going to write, or I can go down 2 and to the right 1, but then I don't have any more room. My other option is to go up 2, left 1. Up 2, left 1. I have so many students that will not extend the line. You are going to fit as many lattice points as possible until you cannot fit them anymore. So then we are going to sketch a line that goes through all of those points. And then I'm going to focus on the second equation. So for the second equation, I am going to also identify the y-intercept and the slope. For this second equation, what's our y-intercept? -2, because that's our constant. It just has an x, so that means our slope must be what? 1 over 1. If it's a negative x, it's negative 1 over 1. If it's just x, it's a 1 over 1. So then zooming back into the graph, I am going to start on the y-axis at -2. Since it's positive, I go up 1 over 1, up 1 over 1. This one will have even more lattice points. And we already see that it intersects right here. A system of equations has a solution when the two lines actually cross or intersect. And the coordinates of this intersecting point coincide with the solution we just got above, -1, -3. As you're working on this practice of solving systems of equations by substitution and graphing, if you get different answers, then go back and check your work, because if they don't match, it's either your substitution is incorrect or your graphing is incorrect. Number 2, it does not have the equations in an easy format to graph. It does not have them in slope-intercept form. So we're going to see what that looks like. Anybody else still need this one before I move it? I'll come back to this one. Okay, number 2. If I'm going to solve this system of equations by substitution, I'm first looking for, is there one of the equations, or it might be both, that already has a variable isolated? If so, which one? On the first or the second? The second. So I'm going to take this expression, y minus 3, which is equal to x. And where will I substitute it in? Right here for x or right here for y? X, since it equals x. If it equals y, you substitute in for y. If it equals x, you substitute in for x. So we are going to replace this expression and put it in here. So we're going to have -4 parentheses y minus 3. The rest of the equation is the same. Minus 2y equals to 6. When your new equation has all the same variables, in this case it only has y's, then we know we set it up correctly. Number 1 had variables on both sides. This one only has variables on one side, so we have to simplify by distributive property first. What's -4 times y? And what's -4 times a -3? And a negative times a negative is indeed a positive, so then I just bring down everything else. Before I start moving things left and right, I can, but I want to combine like terms. I want to simplify as much as I can. A -4y, if I combine it with a -2y, it becomes a negative what? And then I'm going to add 12, and that is all equal to 6. What's our next math move? Okay. We're going to have -12 on both sides. -6y is equal to -6 le resto 12, -6 minus 12. Do we have more negatives or more positives or more negatives? I have a -6. And then our last move to solve for y. So therefore, y is equal to positive 1. Now that we know what y is, I'm going to take this 1 and I'm going to substitute it in for this y right here so we can figure out what x is. So I know x is equal to whatever y is. In this case, y is equal to a 1 minus 3. If I have $1 and I owe 3, what do I still have or what do I owe? Do I owe 2 or have 2? Negative 2. And since we have to express our answer as an ordered pair, it's going to be 1, or not 1, negative 2, because first is the x, comma, 1. Since neither of these two equations are in slope-intercept form, we're going to have to convert them. So that's why there's kind of all this space on your worksheet. So I'm going to rewrite this one over here. I cannot graph it until I convert it to slope-intercept form. It's currently in standard form. So all that means is we're going to take this equation and we are going to try to get it to look like y is equal to mx plus b. In other words, we need to solve for y. Okay, the first thing we're going to do to solve for y is we're going to move this term over. What's the opposite of a negative 4x? So we're going to add 4x. So that leaves us with a negative 2y is equal to, can I just combine these two and call it 10x? No, because they're different terms. Because I want it to be mx plus b, I'm going to put the 4x first and then plus 6. What can we do to get the y by itself next? Okay. And we're dividing all terms by this coefficient, which is negative 2. A positive divided by a negative is negative. What's 4 divided by 2? And a positive divided by a negative is also negative. 6 divided by 2. So we are going to graph this first equation. Our slope is a negative 3. Or sorry, our y-intercept is a negative 3. The slope is a negative 2, which I can write it as 2 over 1. So I'm going to go down 2 over 1, down 2 over 1. I can also go the opposite direction so we get as many lattice points on the graph. I can go up 2 and left 1, up 2, left 1. And I'm going to keep going until I cannot fit anymore. And then we have the second equation. I'm going to go to this side of the graph because I've got a little bit more room. We have x is equal to y minus 3. But we want it to look like y equals mx plus b. So on this one, I want to get this y by itself. How do I move that negative 3? And because these are not like terms, I'm just going to have x plus 3. That might not look like y equals mx plus b, but it is. So since I already have the y isolated, this is the same thing as if I have y is equal to, I'm going to put this on this side and this on this side. Now that we have this one right here, what's our y-intercept? Or our b value? 3. So I'm going to go to the y-axis. 3 is right in between 2 and 4. Since we just have x, what is our slope? 1 over 1. Up 1 over 1, up 1 over 1. It is a positive slope. I already see the intersect here. And when we solved it by substitution, we had the solution -2, 1. If I look at the intersecting point right here, the x value is -2 and the y value is at 1, the same answer. So you're going to continue with 3 and 4. You're going to solve by first substitution and then second by graphing.